this lecture, I want to talk about mean as a measure of central tendency. Now, when talking about mean, or what others call average of a set of data, we are talking about the sum of all the data values divided by the number of data values. That which simply means the number of entries, sum of all data divided by the number of entries. That applies for ungrouped data. Symbolically, we use x bar to represent mean, and summation of x to represent the sum of all the values, and n to represent the number of entries. Now, for example, you are told that the marks of 7 students in a mathematical test with a maximum of possible mark of 20 are as stated: 15, 13, 18, 16, 14, 17, and 12. Find the mean. This is basically the sum of all this, as indicated here, where we have 15, 13, plus 18, plus 16, plus 14, plus 17, plus 12, divided by 7. 7, 1, 2, 3, 4, 5, 6, 7 entries. That's the reason for 7 here. So that we end up with 15 as the result of this summation and division. When you're talking about group data, because what we have just discussed is ungrouped, so for group data, the mean is obtained by the sum of the product, frequency, and midpoint. So the sum of f times x over the sum of frequencies, which is f. Okay. For example, we have this data here. These represent class. From 20 to 29, we have 5 entries. From 30 to 34, 4 entries. From 35 to 39, 7 entries, etc. So find the mean. Calculate the mean. We will introduce another column for midpoint, that is x. How do we get midpoint? Midpoint is obtained by summing this and this, 20 and 29, to get 49, then divide by 2. Okay? That will give us 24.5. That's how to obtain midpoint. That applies to all these other parts. Okay? Then we get a column for f times x, that is the corresponding frequency value times the midpoint. So if you have 5 times 24.5, you get this. When you have 7 times 37, you get 259. 1 times 57, you get 57. And that gives us this other column. So now that our formula demands for the sum of f times x, the total sum of this, we can obtain this. This can easily be obtained from Excel. We obtain this, and the sum of f's, which is 48. So we have this divided by this will give us the mean, which is 40.656. As simple as we have just talked about. Now we can try. It's always good to try something after learning a concept. So you try this data here. We have class and we have frequencies. So I have already given the answer here, 21.91519. So try this and obtain this result for practice purposes. Now we can apply this calculation of mean even to stem and leaf plots, which we had discussed earlier as applied in biostatistics. This is obtained by finding the individual sums of the rows SR divided by the number of entries. So for example, we have this stem and leaf plot. This one talks about stem, this one talks about leaf. Finding a solution to that, the corresponding rows will have their sums as indicated, 0.6 plus 0.1 will be 0.7, plus 0.4, that will be 1.1, plus 0.8, that will be 1.9. The same applies to this and this other one and this. Okay, so the total sum of all this gives us this. Therefore the mean from stem and leaf plot is actually 22.5 divided by 15. 15 is this number of entries. Now next we shall be talking about median and mode. Remember to subscribe.